Come back. Example 2. Find area between the curves y equals x cubed and y equals 3x minus x squared. Again, let's draw the graphs. Y equals x cubed is the cube function. And y equals 3x minus x squared, that's a parabola, upside down parabola. So notice these two curves meet at 1, 2, and 3 points. Okay. So you want to find area between these two curves. Notice over part of the interval, x cube is above the parabola, and in the other part of the interval, the parabola is above the x cube function. So question is, when does that happen? In other words, you need to find the intersection points. Actually, all you need are the x coordinates. You don't even need the y coordinates, only the x coordinates. So from x equals 0 until a certain number, the parabola is above the cube, and likewise for a certain x coordinate until 0, the cube function is above the parabola. All right. So identify the intersection points. All we need to do is equate the expressions defining the two curves. X cube equals 3x minus x squared. So x cube is 3x minus x squared. Move the x squared to the left, move the 3x to the left. You have x cube plus x squared minus 3x is 0. Common factor of x squared plus x minus 3 is 0. So notice the first factor fetches me x equals 0. The second factor is a quadratic. I need to use the quadratic formula, and assuming my calculations are correct, I get two roots. A, -1 plus square root 13 over 2. B, -1 minus square root 13 over 2. So notice this is going to be a negative number, so that would correspond to this point. And this is going to be a positive number, so that corresponds to this point, whereas x equals 0 corresponds to the middle intersection point. So what happens? From the first negative point to 0, x cube is above. So b, that's the negative x value, b to 0, x cube is the first function. So x cube minus the second function, dx, that integral, plus from 0 to the positive value, a, the parabola is the first function minus x cube. All right. So you're going to find these two integrals, right? So all we are doing is simplifying and proceeding, right? Integral, 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 integral. So notice the limits b to 0, 0 to a. So at 0, I'm only going to get zeros, right? At 0, I'm only going to get zeros. So all I'm going to get is value for b and a. A is going to give me a positive value. I've written it like that, minus b substituted. So notice b itself is negative. So this expression may be fine, but this is going to be negative, and there is an expression regardless. B is a lower limit, so it's a minus. So I've left it like this. In A's and B's, where A is this number, B is this number. Okay, so that completes the material for the theory for section 5.1. Couple of examples. Next videos will cover problems from web work. Notice this entire material has closely followed the text by James Stewart, the textbook for our course. Okay, so next videos will cover problems from web work. Until then, bye.